Okay, we are now going to talk about compound interest here. Let me get it to focus here. Okay, so for the section on compound interest, there's actually kind of three main ideas, and each one has its own formula. Okay, so there's the compound interest formula, the APY formula, and the present value formula. So we'll have a video for each one of these, starting with the compound interest formula. Okay, so let me describe real quick what compound interest is, and then I'll give you the formula. So the idea is kind of like when you go to, let's say, Veridian, and you invest your money in a CD, that's a certificate of deposit. I think at Veridian, most of their CDs, they actually compound the interest every quarter. So what that means is 4 times a year, they're going to compound the interest. So what it means is you invest your money after the first quarter, the first 1/4 of a year, they're going to calculate the interest that your investment has earned, and then they're going to add that back into your account. They're going to add it to the principal. So over the second quarter, you're going to make interest not just on the original principal, but on that new amount. And then at the end of the second quarter, they're going to add it back in. And then over the next quarter, you're going to earn interest on all of that. And then they're going to add it in. And each quarter, they're going to add the interest in. So you're essentially making interest on the interest. Okay? And each quarter, the amount of interest you earn will actually begin to increase as your account gets bigger. Okay, so here is the formula for the compound interest. So this is the compound interest formula. And what this gives is the amount that the investment is worth after a certain amount of time. Okay, and it's going to be the principal, which is the amount you invest, times 1 plus R over N, and then you raise to the N times T, and that's going to be an exponent up there. Okay, so I need to tell you what all these things are in the formula. So A here is the amount investment is worth after time t, after so much time, it'll the formula is going to give you the amount the investment is worth. The P is your principal, and basically that's the amount that you invest at the beginning. Okay, now this will always be 1. That's just part of the simple interest formula. So R is going to be the annual interest rate. So for the compound interest formula, the interest rate will always be annual interest. So that keeps this kind of a little simpler than the simple interest formula in the fact that you don't have to worry about the rate. It'll always be annual interest. In here, we'll talk about a little bit more in a second, but this is the number of times compounded per year. Okay, so like when it's compounded quarterly, you're compounding it 4 times a year. So in that case, N would be 4. Okay, and then T is the time. And it'll always be in years. In other words, you always have to convert the time into years, like you do the simple interest formula. Okay, so let's talk about N for a second. Okay, there's different possibilities for how many times the interest is compounded. Okay, so the most common are annual. So the interest is compounded annually, semi-annually, quarterly, weekly, monthly, and daily. And so these are the most common ones, okay? But if it's compounded annually, you're just compounding it once a year. One time, at the end of the year, you put the interest back in. Semi-annually would be twice a year, okay? You're compounding it halfway through the year. Quarterly is 4 times a year. Weekly, well, I should have had monthly first, but weekly would be 52 times a year. Monthly would be 12 times a year, so I should have listed those in reverse order. And it doesn't matter. Daily is 360 times a year, okay? And so notice daily here, we're using the banker's rule, right? 360 times a year. Okay, so let's do some examples of this, and maybe I can have that formula here. Or here, I got an idea. Maybe what I can do is I can write the formula up here. Okay, so I'm going to invest $5,000 at 5.21% interest compounded quarterly for 3 years. And I always start with this one because I did an investment. One of my first CDs I got was at Veridian, and the interest rate was 5.21% compounded quarterly. And I can't remember if it was quite 3 years that I invested the money, but it was around that time. And so right now interest rates are nowhere near 5.21%. They're like somewhere in the 2%, 3% range. Okay, so at the time that I made my first investment, the interest rates were pretty good. Okay, and so they took a dip, I think, in around 2008 when there was kind of a recession. So okay. So how much is my investment worth after 3 years? So I take the $5,000, my principal, I multiply that by 1 plus R over N, so I convert the interest rate to a decimal, like that. I divide by N, so what is my N if it's compounded quarterly? So your N is 4, so that'll be 4. So notice that N gets used again up here in the exponent, right? This will be 4 as well, okay? And then my time is for 3 years, so I'm going to multiply that by 3. So it'll look like that, okay? Now let me show you how you put it in your calculator here. It's really important that you get this in there right. So start by putting in the principal, and then you multiply that by 1 plus 0.0521 divided by 4, and then parentheses, and then you have the exponent button. And on this calculator, it's like a little arrow. It's right here, and it looks like an arrow kind of pointing up to where the exponent would go. Okay? And that's my exponent key. I think it's like that on the TI-30. Now there are some other calculators that have different buttons. So some of the ones I've seen is a button that looks like this, Y over X. And I've seen one that has like an X with a little square up here indicating that's where the exponent goes. Okay? But for this one it looks just like that. And now it's very important that you don't put your exponent in your calculator like this with a parentheses, how I have it here. I have it like this because I want to make sure that you're going to multiply those two. Okay? And so I just write it like that. That's how I write it. But what you want to do here, okay, if I didn't do this right, if I put like 4 times 3 like this, if I put that in my calculator, this is going to raise this whole thing to the 4th power, and then it's going to multiply by 3 because your calculator knows the order of operations, and you do exponents before multiplication. Okay, so this will raise things just to the 4th power, but you really want it to multiply first and raise this all to the 12th power. So you need a parentheses around the entire exponent there. Okay, so that's what it would look like. So let me type it in and show you. So it'd be 5,000 times 1 plus 0.0521 divided by 4. Raise that to 4 times 3, and notice that's in parentheses. So it would look just like that. And my investment here is worth $5,839.99. So that's pretty good. I invested $5,000, and then 3 years later, this is the amount that I got. So I made like $839.99 interest just for investing the money. So that's not bad. Okay. Now, of course, that is a pretty good interest rate, isn't it? So, and 3 years is quite a while, and $5,000 is a lot of money. Okay. So now this is kind of it's a lot less money here. The interest rate, this is kind of what they are right now, around 2.7%. And this is only for 17 months, not 3 years. So about half the time. So let's figure out how much this investment will be worth. So it'll be $750 is my principal. And then I'll have 1 plus 0.0275. So now it's compounded daily here. So what that means is it's getting compounded every day. So they're adding the interest in every day. So there's always a little bit more every day that it's calculating interest on. And so it kind of makes sense. The more you compound it per year, the better your return is going to be. I mean, the more interest you're going to make. So it is good that you're compounding this every day. Okay? But what you'll find out as you do these is that even though you earn a little bit more, the difference isn't that big between like a quarterly interest rate and a daily interest rate. If it's compounded quarterly and compounded daily, you will make a little bit more with the daily interest rate, but it might only be like $1 or $2 more. It's not like a huge difference. Okay, and then we're going to raise this to, I need to use the 360 again, and then the 17 months, I can't put 17 here because that would be investing for 17 years. So I got to convert the months into years by dividing by 12. So it would look like that. Okay, now when I put this in my calculator, I got to do 750 times 1 plus 0.075, I'm sorry, 0.0275 divided by 360, and then my exponent key. And then it looks like here you want to divide first and then multiply, but as it turns out, you can you can do this, multiply and then have 17 divided by 12. It's kind of like in the simple interest formula. I mean, normally you think you would need a parentheses around this, and you normally would, but because of the way you multiply fractions together, this will give you the same thing. So technically, you just need one parentheses around the entire exponent, like that. Okay? If you want to put another parentheses around just this, that's okay too. Okay? But you don't need it. So, putting this in my calculator, it'll be 750 times 1 plus 0.0275 divided by 360 raised to the 360 times 17 divided by 12. And so it's going to look like that. And I get $779.79. So that's how much my investment will be worth after 17 months. Okay, so let's do a couple more examples here. So I'm going to invest $1,350 at 6.4%. 0.00643% interest, compounded semi-annually for 250 days. So semi-annually, can you remember what that was? That would be twice a year, right? So, I'm not seeing where my table is. Oh, there it is. So semi-annually here was 2 times a year. So your in is 2 in this case. So I got $1,350. 1 plus 0.0643 divided by 2. And then I'm going to raise this to 2 times. This is for 250 days, so I got to use the banker's rule to convert that into years. So 250 divided by 360. Okay, so I'm just going to put this in my calculator, and you can see how it looks. So 1,350 times 1 plus 0.0643 divided by 2 raised to 2 times 250 divided by 360. And I get $1,410.66. And that's how much the investment would be worth after 250 days. Okay, so now let's do one last problem. And that is, we're going to invest $35,000 at 11.2% interest compounded monthly for 35 years. So now I'm going to be investing a lot at a high interest rate for a long time. And we're going to see that this investment we're going to earn a lot of money on this, okay? So let's see, it's $35,000 at 11.2% interest. So this is 0.112, and divide that. This is compounded monthly, so monthly is 12 times a year. So divided by 12, raise this to 12 times 35. Okay, this is already years, so I can just keep it as 35. So let's see how much this investment is worth. This will be fun. Okay, so 35,000 times 1 plus 0.112 divided by 12 raised to 12 times 35. And wow, it is worth $1,732,235.0. Wow, talk about a nice return on your money. I invested $35,000. I get over $1,732,000. Okay, so let's talk about this just for a second. This would be kind of like what you do when you invest money for your retirement. Okay, nobody has $35,000 to invest. Maybe if you inherited money from a relative and you invested it all right now, you could invest that amount. Okay, but normally when you invest for retirement, you're investing a little bit maybe every month out of your paycheck. Okay, and so that does build up over time. Okay, and you're going to end up by the time you retire, which is like 30, 35, 40 years after you start investing money, you're going to end up with a lot of money, as you can see here. You just aren't going to have this much right at the beginning, but that will build up. Okay, but let's talk about this interest rate, 11.2% interest. So to earn this amount, you need a really good interest rate, and you're not going to be able to find this like in a CD or something. Okay, CDs don't earn this much interest. So how in the world could you ever earn 11.2% interest? Well, the way that you do this is through a financial product. So it would be like, I don't know if you've heard of Vanguard. There's other different companies where you have people who take money and invest it, and they diversify it into different stocks and bonds, okay, and then they can earn quite a bit of interest. So if you actually get an investment that you buy it like a mutual fund that has a high risk, it can earn, you know, anywhere from a negative amount of interest up to like 20% interest, and it fluctuates back and forth. But what they say is that over any 10-year period or whatever, the average increase is around 11%. Okay, it could be a little bit less, could be a little bit more, but it's usually around 11%. And so this is how you would actually get a interest rate that's even close to this. Okay, now you don't have to be, you know, someone that knows how to invest money in stocks and bonds. You would just you would buy the product, a financial product, from someone who invests the money, who's been trained in that, and they're going to invest your money and move it around. You don't have to do that. And of course, they're going to make a little bit of money, so they're going to earn a certain percentage. Okay, but you still will get a really good percent. And so that's how, if you actually want to invest money for the long term, then you want to get a product like that. And then when you're young, you want to do high risk, because over time that'll increase more. But then as you get closer to your retirement age, you want to lower the risk, and you're not going to earn quite as much. But at that point, hopefully you got a good amount. You just want to keep that stable and maybe have it grow with inflation. Okay, but that's sort of the overall idea for like investing money for your retirement. And of course, those investments are compound interest. Okay, a simple interest formula, you wouldn't earn nearly as much money. You can actually find out how much you would earn with a simple interest formula. You would just use a simple interest formula at 11.2% interest for 35 years. Let's see what this would be. Times 0.112 times 35. And so this would be $137,200. And so the amount that your investment would be worth would be the $35,000 plus $137,200. And so your investment here would be $172,200. So in simple interest, you don't even make $200,000, but with compound interest, you make a huge difference. The difference is very big. And what happens is the difference is increasing. I mean, it starts increasing more and more rapidly over time. So let's say this is your $35,000 that you invest. Just real quick, your simple interest is going to go up like this, okay, and the slope of this line is going to be the interest rate. Okay, so the higher the interest rate, the more that line's going to slope. But compound interest is exponential, and exponential is going to kind of go up like this, and at the beginning it's not going to be as big a difference, but then over time the difference starts increasing more and more rapidly. This will just go up like this will go up like that, and the difference as time goes on gets very, very large. Okay, so that's the compound interest formula. In the next video, we're going to talk about the annual percentage yield, the APY, and we'll talk a little bit about why that is important.